Hi everyone, welcome to another exciting session of Lambda Test Experience series. Through XP series, we dive into a world of insights and innovation featuring renowned industry experts and business leaders in the testing and QA ecosystem. I'm your host, Kavya, Director of Product Marketing at Lambda Test, and it's a pleasure to have you with us today. Today's session is about deep diving into Playwright and exploring how this cutting edge tool is transforming the automation testing landscape. Before we kickstart today's discussion, let me introduce you to our guest on the show, Parul Rana. Parul is the lead QA automation engineer at Binmile and brings nearly 11 years of experience in quality assurance. Her expertise lies in ensuring the highest quality standards through rigorous testing and innovative solutions. Beyond her professional accomplishment, Parul is an avid reader and passionate traveler. Parul will today guide us through the latest features of Playwright, demonstrating how it simplifies end-to-end testing and discussing real-world applications and best practices. So let's get straight into the heart of today's discussion. Parul, can you tell us a bit about your current role and what Binmile offers in the space of testing as a service?
Thank you, Kavya, for having me. I'm happy to be a part of the XP series by Lambda Test. I have around 11 years of work experience in software development and testing while working on projects with clients from US, Europe, and India. My industry focus varies from healthcare, banking, payment solution domains. Currently at Binmile, I work as a senior SDET and test automation lead. In my current project, I cater to a European e-commerce chain, and I plan functional and regression tests, and I design automation test frameworks from scratch. I write utility libraries, and I have worked with tools like Selenium with Java, Playwright with TypeScript. Binmile is a digital engineering company founded in 2014 by Mr. 𝐏𝐚𝐫𝐵𝐻, and as of today, we are ranked 45th out of 500 high growth companies in Asia Pacific. We are the preferred software solutions provider in the industry in 15 plus industry domains.
That is great to hear that you're working across multiple industries, Parul, and have such a vast experience. Also, congratulations to the Binmile team on the accolade, of course. So, moving on to the next question, right? How do you decide which test automation tool to choose from all the tools being offered in the market today?
There are many factors that I consider when I'm deciding on which automation tool to pick. The most important is to understand the project's requirements. What type of application will I be testing? Is it a web application or mobile or a desktop or an API? And what testing it needs to be automated? Like if you're testing functionally testing an API, or am I writing an end-to-end regression test for a web or mobile application, or am I doing performance testing? I also consider my team's skill set, like which programming language the testers are familiar with. Are they happier with using a codeless tool? I have to see which language they're, if I pick up a new tool, will there be a learning curve for a new language or the tool? And one other aspect is the project's budgetary constraints, because there are more both open source and commercially licensed tools available in the market. So cost of the tool alongside the training my team might require, I need to consider those aspects. And nowadays, there are also tools available with very intuitive interface and features that simplify test creation and maintenance. So all those pointers also I keep in mind. And will I be able to do data-driven testing using the tool? Because that would allow me to have more increased test coverage. And finally, is it the tool is providing an easy way to integrate with the CI/CD pipeline, and I don't need to use any third-party tools. So these are the factors that I consider.
Thank you, Parul. It is interesting to hear how you're navigating through all these options and even variables within the team, like budget, team skills, as you said, seamless integration of the tool with CI/CD pipelines, and of course the UX part of it, so as to find the perfect perfect fit for your needs. Interestingly, based on the topic, of course, of the day, I know that you have chosen Playwright for your current project. So my question is, why did you choose Playwright to begin with?
The project I'm working on is a Node.js based web application, which is being developed using TypeScript. And the clients wanted that the developers should be able to understand the test scripts that I write. So TypeScript was the preferred language for development of tests. And my aim was to write end-to-end tests quickly while also keeping in mind that the test should not be flaky. And Playwright provides out-of-the-box features that streamline test writing. And I prefer this for its capabilities like auto waiting that intelligently waits for elements to load and process some processes to complete before it goes to the next test steps. And this helps to remove test flakiness. And I also needed my tests to run in parallel for faster test execution. And Playwright provides this out of the box again, a capability to do parallel testing. And if you see, Selenium itself doesn't provide built-in support for parallel testing. You'll need to integrate it with other testing frameworks like TestNG or JUnit that offer parallel execution capabilities. And you need to use annotations and XML configuration files that to specify how the parallel test execution is to be done. And therefore, it's time-consuming to write the scripts using Selenium. So that is one thing I have to consider. So, and the other thing was that Playwright supports headless browser testing, which it makes it ideal for CI/CD pipelines. So those are the reasons I chose Playwright.
Thanks again, Parul. I mean, thanks for highlighting the out-of-the-box capabilities of Playwright. That definitely seems to play a major role, especially given your role as lead QA automation engineer, right? And what I'm able to understand is when you have to look at two aspects of it. One is from the client's perspective, how best to choose the right automation framework for them, while also trying to understand your team's capabilities on the other hand. And yeah, thank you once again for mentioning how Playwright fits best over here. I know that you briefly highlighted this, but let's deep dive into it. How is Playwright able to provide faster test execution?
Okay, so Playwright uses WebSocket connection for bidirectional client-server communication, and this method is faster and more efficient compared to traditional HTTP communication. And for this reason, we see that WebSocket is being used by Selenium starting from version 4.5 also. And the other reason is that Playwright utilizes multi-process architecture, where each browser instance runs in a separate process. So this allows parallel execution tests across different browsers or even within the same browser using multiple browser contexts to run, in their own separate windows contexts. Selenium, on the other hand, typically relies on a single browser instance per test. And this leads to, sequential execution. In order to achieve parallel testing using Selenium, we need to integrate it with other testing frameworks, like I said, TestNG, and which typically requires doing a lot of configurations. And which, for this reason, Playwright is a better tool, I feel, because it is providing parallelism out of the box for test development, and this makes it faster in execution. Additionally, Selenium WebDriver's instances are not inherently thread safe. So if you want to run multiple tests concurrently in a single WebDriver instance, this can lead to unexpected behavior. You'll need to address this. If you want to address this, you have to create separate WebDriver instances for each parallel test using techniques like thread local storage or isolate browser sessions. On the other hand, Playwright uses a multi-process architecture where it uses different worker processes to isolate these tests. And each worker process has its own browser context, which is equivalent to like an incognito mode like profile. Okay, and this means that each test it's running in its own isolated environment, having its own local storage and session storage and cookies. And now, another reason I think Playwright is faster is because it uses auto waiting mechanism. And that is that Playwright automatically waits for elements to load and actions to complete before proceeding to the next steps. And this eliminates using hard waits and explicit wait commands like WebDriver waits in Selenium. And that can cause the tests to be slow unnecessarily. And Playwright supports headless browsers, which are browsers that don't run, they don't have a GUI, graphical user interface. And this further improves test execution speed, as headless browsers are typically faster than traditional browsers. And Playwright communicates with browsers using DevTools protocol, which is more efficient protocol than WebDriver protocol used by Selenium. And this also leads to faster test execution times. And Playwright includes a lot of built-in browser automation features, such as ability to take screenshots, record videos, and interact with the browser web elements. And this eliminates the need to use third-party libraries, and which further improves test execution speed. And in addition to being faster, Playwright is also more reliable framework because it is built on top of Chromium, which is the same engine that powers Google Chrome. And that means that Playwright is less likely to encounter compatibility issues with browsers.
Thank you so much, Parul. Two major factors is, of course, the faster test execution part of it, and then there is, of course, the reliability factor that is sort of making Playwright more efficient and useful for automation engineers. And of course, speed is a very crucial part when it comes to any project, any client, especially when we talk about enterprises, right? The speed and test execution can really make a huge difference in the development cycle per se. So, good to hear that. And you also mentioned that Playwright eliminates test flakiness. Can you explain how that is achieved?
Flaky tests often rely on fixed time delays, hard waits to account for page loading or element interaction. Playwright discourages this because the network speeds and rendering times, they can vary, and the wait time can either be insufficient or excessive. Instead, Playwright provides a built-in waiting mechanism that is more robust, and then using the hard waits. And these methods wait for a specific condition to be met before proceeding, ensuring the test interacts with the page only when it's ready. For example, you can use wait for selector that will wait for the element to be visible and present in the DOM before interacting with it, or wait for load, like it wait for different loading states of the browser, like DOM content loaded or network idle state. So this eliminates the need to use any kind of hard waits. And Playwright offers various locator strategies like CSS selectors, text content, so that you can choose the most stable approach for your elements. Playwright also configures test retries. And when a test fails, it can automatically get retried a certain number of times before being marked as definitely failed. And this can eliminate, occasional flakiness, which is caused by some external factors. In special scenarios, you can also use the slow-mo option in Playwright configuration. This artificially slows down the test execution speed, giving the page more time to render and elements to become interactive. And it potentially helps to identify, timing-related flakiness if there is.
Thanks, Parul. Interesting, because at the end of the day, we are all trying to achieve that stability factor. And clearly, with Playwright, your team has been able to, in fact, not just reduce, but kind of eliminate the test fakeness part of it. And that is a day-to-day struggle for all the testers out there. So I can only imagine how much of a relief that must have been for you. And of course, all that you have mentioned about Playwright definitely seems interesting. But what exactly makes Playwright a modern test tool?
Well, Playwright leverages Chrome DevTools protocol as compared to other tools that use like classic WebDriver. WebDriver is nothing but like a remote control for your browser. It is an API that allows you to control the browser through your code. This helps you to automate tasks like navigating to a page, finding a web element, filling out the forms, clicking a button. So it's basically it is stimulating the user's interaction with the browser. However, it has limited control over browser internals and debugging capabilities. Whereas Chrome DevTools protocol is a remote debugging API that allows developers to communicate with a running Chrome browser, and it can be used to inspect the browser's state and examine the underlying code of the web page, like the HTML structure, the CSS styling, JavaScript. And you can control the behavior of the page by directly modifying the code and see the changes reflected on the page in the real time. And this allows for a quick experimentation and like debugging to stimulate different styling issues. And that's one reason. And DevTools also provide device emulation capabilities that you can simulate different screen sizes and different user agents and see how your web page looks and functions. So you can test how it will appear on desktop, tablets, or mobile phones. And CDP also provides ability to capture screenshots, monitor network requests and responses, and manage browser state like local storage, cookies. Playwright leverages all these capabilities of CDP, helping it gain more control over the browser's behavior during test execution. You can capture the screenshots, you can record browser sessions, you can see the browser state through the CDP, and you can access the detailed information of the DOM. And using this, you can assert on element properties, styles, even the presence or absence of specific JavaScript functions in the page context. So that's why that's how the Playwright is, I feel, is a modern tool in all respects.
Thank you, Parul, so much for shedding light on that. It is really interesting to see, how Playwright has sort of evolved to meet the current testing needs. And especially now, I've recently read that Playwright has surpassed when it comes to weekly downloads, for instance, it has surpassed even Cypress. Um, and that has happened for the very first time. So, yeah, thank you so much for sharing those insights. So, moving on to the next question, can Playwright replace Selenium to become the most popular testing tool being used?
Well, that's a trick question, I think. Currently, Playwright has the best features any modern testing tool can provide. There is a healthy competition in the industry today, and it is exciting to see how other automation tools like Selenium had to come up with its version 4 to make up for some of its shortcomings. Currently, Selenium team is working on their WebDriver BiDi project, which will revolutionize cross-browser testing. Playwright has its own set of drawbacks, like it supports only Chromium-based browsers like Chrome. It supports Edge, but Playwright can't directly control the official Microsoft Edge browser. It can achieve some level of automation by launching the Edge through Chromium emulation, which might not perfectly replicate Edge's behavior. It has good support for WebKit, but Playwright uses custom patched versions of Firefox for automation, so it won't work with branded versions like the Firefox ESR extended support release. And Playwright also prioritizes supporting the latest browser versions. So there might be limited functionality or no support for very old browsers like the Internet Explorer version 11. So considering all these drawbacks, it is difficult to say if Playwright is the winner here.
Thanks, Parul. As you said, yeah, it will be interesting to see how the testing community sort of responds to this. But yes, at the end of the day, each tool has its set of advantages and pros and cons, if I was to put it like that. And it could lead to very exciting developments. And of course, based on the project requirements, as you had initially said, right? Based on the project requirements, um, e- each of these tools would be useful for the testing teams at the end of the day. So moving on to the next question, you said that WebDriver BiDi aims to revolutionize cross-browser automation. Can you please elaborate on this a bit?
Selenium quickly realized that it had to move away from using classic WebDriver, and with its version 4 started using WebSockets. It also started using Chrome DevTools protocol. However, one of the biggest challenges was maintaining the compatibility between Selenium and CDP, because Chrome releases frequent updates and CDP can change alongside those updates, causing a lot of breakage in the Selenium. WebDriver BiDi protocol aims to overcome such issues. Like CDP, it uses WebSockets, for bi-directional communication between the browser and the test runner to make communication efficient and faster and having low network latency. But again, like CDP, it aims to provide more fine-grained control over the browsers. However, CDP was made for Chrome, while BiDi aims to provide more flexibility for testers to choose any browser, as it is being designed to support all the browsers, and it will be based on the W3C web standards, and all the browser vendors will be implementing it. WebDriver BiDi also aims to provide more stability. Like I mentioned, Chrome DevTools is very tightly coupled to the Chrome versions, and they do not guarantee backward compatibility. WebDriver BiDi, on the other hand, aims to be more standardized and stable and will guarantee backward compatibility with different browser versions, so that there is, the least amount of test breakage. And BiDi also helps it will help testers to subscribe to global events across multiple windows and tabs. With CDP, if you want to listen to any event like, console logs or JavaScript exception, etc., you have to, go to the specific window or tab, and then you have to send specific commands to attach to it, and you have to create a separate CDP session with the tab or the window. And you can only listen to a specific window or a tab. However, BiDi is going to make it easy for you to listen to events globally across different windows and tabs, and this can be a very helpful feature for the testers. And BiDi also aims to reduce the code complexity as compared to CDP. While CDP, we need to write many commands in order to create the CDP session and get some information from the browser. The same can be done with lesser number of commands with BiDi. So it will reduce the complexity and also the network latency. So we can say that BiDi protocol will definitely revolutionize the test industry, and the only disadvantage as of today that I can think of is that it's still in development and we can't use it as of now. But I think they have begun to roll out the support for Java, but it is still in development for other language bindings.
Good to hear how Selenium WebDriver BiDi is set to change the landscape when it comes to automation. And what is next? I mean, what do you think will be the next big thing apart from BiDi in test automation?
Well, artificial intelligence, AI is the buzzword today, and it is definitely going to bring a lot of changes in the way we test and we design tests. AI will be able to, automatically generate test cases based on usage pattern, user stories, requirements, ensuring there is more coverage of all the test scenarios. And AI algorithms will be able to detect changes in the UI and automatically update the affected test scripts and reducing the maintenance effort. And such scripts will be like able to self-heal from any code changes. And currently there are third-party tools in development as of today that will act like a wrapper around tools like Selenium and Playwright and help it enhance its capabilities. However, I haven't personally used any such tool yet. However, at Binmile, I was involved in testing an AI-based chat bot that was trained on the vast rules and regulations of the banking domain. And I was mostly involved in the workflow automation, and it was quite a challenging project to work.
Thank you for also briefly sharing about an interesting project that you worked on. And coming to the current project, what challenges have you faced in it while using Playwright, and how have you overcome them?
Uh, Playwright, as you know, it supports parallel testing, but in some cases, it's not the ideal solution. For example, if your tests rely on data or state modifications from previous tests running in parallel, it can lead to unexpected results. Like imagine two tests trying to log into an application and the same username at the same time, and parallel execution can conflicts and test failures. And suppose if you have test interactions with shared resources like database connection or file system, parallel test execution might lead to race conditions or data corruption. So multiple tests, access and modify, if they're modifying the same data simultaneously, there can be inconsistencies. So in these cases, we need to use the serial mode of execution. So there were cases in my project also where I was facing this challenge. However, as you know, I already said that I preferred to use Playwright because of its parallel testing out of the box capabilities. So I wanted to find a workaround in how I can achieve parallel testing in cases where the same DB tables or resources are being used. So I'll share the screen right now from my system and show you some code and how I was able to achieve this.
Perfect. Great. The screen is visible now.
So Playwright provides support to globally set up for the authorization and authentication of the users, and you can handle different states of the users across your parallel tests. So I'll show how it is done. So this is an auth setup file that I've created that is basically having like multiple tests. They are called setup. I'm calling it setup here. And here, this you can see is login page, which is taking the page, the fixture. And the login page is nothing but your page object, which will contain all the web elements and they will be mapped to your actual page, login page. So here, I'm just going on to the page and then I'm calling the method to login. I'm sending the user ID and password. If you can see here, this is the environment configuration that I'm using. So process.env, first I will set the all the email and passwords in the process environment. And then I will log in and then wait for a URL to come to the home page. And after that, I will store the state of that user using context.storage state. And here at this file path in the JSON format, the state of the user, authorized user, is saved. Similarly, in the next worker process, the same thing happens. And in the only difference being that here, a different user ID and password is used. So simultaneously in parallel execution, 3 different worker processes are happening. They're running these tests in parallel, and all of them are using different users to log in. And after that, there is another configuration that I have to do in the Playwright config ts file. Here in the project section, I'm setting up for the auth.setup file, I'm setting it up as a project. And I'm making the current project, which is using Chromium, as a dependency for this setup. So this is always run before any tests in this project. So what happens is that before any test begins, the users will log in and that state of the user is saved to a file. So next time when another next test starts, the user doesn't have to relog in. And different worker processes can maintain different user login states, which will not interact or affect with each other. And it will not, if we can test scenarios in which in case we are using this, like for example, we're placing an order, such cases in which same resources might be used and it's not possible for different for the same user to be placing order at the same time. If a same user is placing 2 different orders, it's not possible in that case to test. So for that, I require like 2 different test users, and then I'm able to place 2 different orders at the same time. That'll be possible. So for such cases, we can use this. So here you can see that after I make the configurations and I run the tests, these files will be created, which is just saving the state of the user, like I said, like the cookie information, the access token values, and the state of the users, like user ID, session IDs. Okay, so this is the final file, that is my test file, which contains the actual tests that need to be done. So here I'm injecting in each of those tests the user's stored state, that authorized logged in state. So for the first test, I'm using the user 1 authorization. For the second test, I'm using the user 2 authorization. So these tests are running in parallel and they're using different user states. And you can do many things from it, like, your tests can go like add a product, place an order. You can write those steps in this part. And the main thing is that you can use the stored state and inject it into your tests and run them in parallel, having different authenticated states of the users, and that can help you run those tests in parallel, which in general is difficult to do. And because in the serial mode, what happens is sometimes if you will have like 200 tests, and on the like 150th test, if it fails, then it Playwright skips all the rest of the tests. So that becomes the difficult thing. You have to again reschedule the tests and run all the tests, fix it again. It becomes cumbersome. So I in many cases we can avoid that and still go for the parallel test execution, in which case even if there is a test failure, only that test is failed and execution of other tests keeps happening. So this is one scenario how you can achieve it. Thank you.
Thanks for sharing these insights, Parul. I'm sure these are some very useful tips and workarounds for testing teams that they can implement while they are working on a project, of course. So, as we wrap up today's conversation, I would like to thank you, Parul, for your insightful presentation, as well as the tips that you had to share on insights on Playwright. I'm sure your practical demonstration along with the insights must have been very useful for our audience when it comes to giving them a clear understanding of how to leverage Playwright, which is a powerful tool for modern testing needs. To our audience, thank you so much for joining us today, and stay tuned for more episodes of Lambda Test Experience series, where we continue to bring cutting-edge insights from industry experts. Once again, thank you, Parul, so much for your time.
Thank you, Kavya.